complex that only a half a dozen scientists in the whole world can understand them. But times have changed a lot since then, and I'm sure many of you understand Einstein's theories of relativity better than some of those scientists did when I was graduating from high school. And I don't say this to be immodest at all, but I think I understand Einstein's theories of relativity much better than any of those scientists did, because I've had the work of thousands of other scientists to read and to learn from. So it is really knowable. And one of the things that Einstein's theories of relativity did is, particularly his special theory of relativity, it destroyed the whole basis of secular materialistic science. It essentially destroyed Newtonian physics. Now, it didn't destroy it to the degree where we'll never use the Newtonian physics anymore, but it destroyed the faith that we had in it that Newtonian physics was actually true. It turns out Newtonian physics is not actually true. It is absolutely incorrect. But it is incorrect by such a tiny amount that we can still use it in everyday life, and even in a lot of science. Such things that are so simple as the adding of velocities. Would everybody agree with that? V1, velocity 1 plus velocity 2 equals velocity 3. Does that sound reasonable? In other words, if you were on a motorcycle going 40 kilometers an hour and you throw a ball ahead 30 kilometers an hour, you add those two velocities, and how fast would the ball be going? Right? So, and that's what Newton told us. Do you think that's true? See, that's just not true. And Einstein's special theory of relativity says that it isn't true. That velocities do not add like numbers. Because velocities are not absolutes. Numbers are absolutes, but velocities are not absolutes. Velocities are determined by what they represent changes by how fast they are going. So if we're going really slow, like 30 and 40 kilometers an hour, it isn't going to equal 70. It might equal something like that. And in Einstein's special theory of relativity, if you were to add those two velocities, 30 and 40 kilometers per hour, it would actually show you that number. So Einstein's special theory of relativity looks at the world the way the world really is. Newton's theories in physics look at the world the way it appears to be. And when you're going very slow, the way it appears to be is very close to the way it really is. But say, for instance, we were in a spaceship that was going 0.9 SOL, speed of light, and we're going in this spaceship like this, and we shine a flashlight ahead, or we shine the headlight on the spaceship. We shine it ahead, and light travels at the speed of light. So the spaceship's going 0.9 the speed of light, and we shine a light ahead that is going. Now, if we were to use Newton's theory, we would say this equals. But according to Einstein's special theory of relativity, so it makes a huge, huge difference. A difference of 270,000 kilometers per second. So at high speeds, we can see that Newton isn't even anywhere close to what is really going on. But at slow speeds, it's very difficult to tell. So this is why I say Newton's theories are still useful in everyday life. But it's important that we realize they are not telling us the truth about reality. So therefore, the philosophies that were based on secular materialistic science, once secular materialistic science has been proved untrue, therefore, it is logical to say that the philosophical implications of secular materialistic science have been proven untrue. And then the cultural practices that come from the secular materialistic philosophies that came from the secular materialistic science, they are also incorrect. And so we need to alter the way the world is today on the basis of the way the world really is, not on the way the world appears to be. And as I'll be talking about in a few minutes, one of the things that Einstein's special theory of relativity allows us to do is have our first scientific proof of the existence of God. On the proofs of the existence of God, there's a really ancient proof of the existence of God that has held up and has never been successfully refuted. Although in the 20th century, a British philosopher, famous British philosopher, whose name escapes me at the moment, thought he came up with a way to refute that proof, but it turned out he was wrong. Bertrand Russell was the name of the philosopher. He thought he could refute this philosophical argument. So the best argument there had been in the past for the existence of God is essentially a logical or philosophical argument. And it's called the watchmaker argument. If you were to look at your watch, right? So you look at your watch or my watch, and you say to yourself, and you ask the question, did that watch just come to be the way that it is, or was there a watchmaker who made that watch? Well, it's obvious, right? The watchmaker made the watch. The watch, all the different atoms that make up that watch from the different elements didn't just happen to get together in such a way as to make a watch. The probability of that is so low, we say that probability is 0. So therefore, there has to be a watchmaker. Then we look at the universe, this unbelievable universe. I mean, how many of you know how many stars there are just in the known universe, the universe we can see, right? The universe we can't see, we know is much, much larger than the universe we can see. But there are limits because of the speed of light and the expansion of space. There's a physical limit to how far we can see out. It's called the light horizon. So we can't see beyond that. We get better telescopes, doesn't matter. We'll never see further than that. So in that bubble of the total universe that we can see, I don't know how many of you know how many stars there are, but I'll write the number on the board because it's a very nice and interesting number. $10,000 billion. That's how many stars there are. A rough estimate. I mean, we might be 2 or 3 off, but very close to that number. So